It was a dark, starless night at the remote observatory when the news hit. Something never seen before had been discovered, something that could change our understanding of the universe forever. Away. Makako, a famous physicist, has just announced that humans have looked into something invisible, the inside of a black hole. The room fell silent as the implications of this revelation began to sink in. What is hidden in these world titans? Does it defy the laws of physics? The air is thick with tension, as if the universe itself is holding its breath, waiting to discover the secrets of black holes. A black hole is one of the most fascinating and mysterious objects in the universe. These powerful animals are invisible to us, but their influence is undeniable. A black hole with a mass 2 to 4 million times that of the Sun is a clear example of this pair. Over the past few decades, our understanding of black holes has grown from ignorance to deep knowledge and understanding. But just when we thought we had these world secrets figured out, Makako's announcement throws everything off course. We have finally been able to look into a black hole, and what we have found will shed light on information that the scientific community has forgotten all along. Before diving into what the Makako team found, it's important to go back to the basics of black holes. Although most of us have a general idea of what black holes are, there are still huge gaps in our understanding. The story began in 1916 when Albert Einstein published his general theory of relativity and predicted the existence of black holes. At that time, the concept of black holes was just a concept, a mathematical curiosity, not reality. It took the scientific community 50 years to find evidence of black holes. The breakthrough came in the 1960s when astronomers studying the constellation Pisces discovered an unusual bright blue star emitting X-rays. This star is not permanent. For the great man, it is invisible. Further studies revealed that X-rays were being absorbed into the mysterious, then known, black hole. The discovery of Cygnus X-1 was an important milestone in astronomy. This provided the first solid evidence that black holes are not just imaginary creations, but real cosmic entities. Cygnus X-1 is 6,000 light-years from Earth and is no small sight. It is about 14 times more luminous than the Sun, and is so dense that its gravitational pull is so strong that the Moon cannot escape. That's why it's called a black hole, a region of space where there's so much gravity that nothing can happen. The concept of a black hole is both fascinating and terrifying. There is a point where the known laws of physics break down, and anything that crosses the threshold is lost forever. But this damage makes black holes a valuable object of study. The more we learn, the more we realize how little we know about them. After the discovery of Cygnus X-1, the search for other black holes began. Scientists have discovered that there are over 100 million black holes in the Milky Way alone. But since black holes are difficult to detect, there is no exact number. However, the presence of millions of black holes in our own galaxy makes studying them more important. The biggest concern about black holes is their energy. Their gravitational pull is so strong that everything in their vicinity is compressed astronomically until it becomes a singularity, a symbol of infinite density. Simply put, black holes are like vacuum cleaners that pull everything in. One of the most frightening aspects of black hole research is the subject of spaghetti. If a person falls into a black hole, they will be drawn to the brink of transformation, a process that will be slow and painful and will die before the final transformation. Although the nearest black hole known to Earth is between 500 and 1,000 light-years away, it raises deep questions and concerns. In 2021, scientists were able to produce the first clear image of a black hole, specifically the black hole M87. This work has accurately imaged the black hole over several nights, with each image providing evidence and understanding. To create a complete picture, the researchers had to stitch these individual images together, showing that black holes are not just empty space. Instead, it is a complex, multi-layered structure. To get to the zero at the center of a black hole, one must first go through 2 layers. The first layer is called the event horizon, the point of no return. When an object crosses the threshold, it dies and is pulled into a black hole. The second layer is the photon spectrum, where light orbits the black hole. Any light that enters this region becomes trapped and cannot escape the black hole's pull. Finally, it is unique in the core, where all matter is compressed into such a small space that the laws of physics are unknown. What makes black holes so difficult to study is that each individual hole is unique. Although they usually follow a three-layer structure, their behavior and characteristics may vary. This is very difficult to teach them with traditional methods. Scientists can observe black holes indirectly by studying the radiation from them and the gas and dust surrounding them. A probe like Voyager cannot be sent into a black hole, because anything that crosses the threshold will be pulled into the singularity and folded into oblivion. This means that scientists rarely study these phenomena in two-dimensional terms, even though black holes are three-dimensional objects. The challenges don't end there. The uniqueness of each black hole and its violation of the laws of physics means that traditional scientific research methods are not suitable. Despite these problems, researchers are not alone. Many theories have been proposed to explain the nature of black holes, and each new theory only adds to the intrigue. One of the most powerful theories is that black holes form when stars collapse. When a star uses up all its fuel, it can no longer produce enough energy to resist the gravitational force pulling it in. As a result, the star collapses in on itself and becomes smaller and smaller until it becomes a black hole. To gain a deeper understanding of black holes, NASA scientists have turned to the subject of the M87 galaxy. Astronomers have discovered a supercharged plume of superheated hydrogen gas spinning at 1.2 million miles per hour. The high power of this rotary throttle is broken, but it is not. Scientists concluded that for this to happen, there must be a large mass at the center of the galaxy, a mass of 2 to 3 billion suns that could become a black hole. However, this is not the only theory about black holes. In 1963, New Zealand mathematician Roy Kerr used Einstein's equations to describe a rotating black hole. According to Kerr, rotating black hole does not collapse into one end, but turns into a ring of fire or a thin disk. This rotating disk of matter, called the ergosphere, is where the laws of physics begin to break down. But perhaps the most interesting aspect of Kerr's solution is his prediction of the existence of the Einstein-Rosen bridge, also known as a wormhole. The idea of wormholes as a way of thinking through space can connect two separate regions of the world or two parallel worlds. Instead of being crushed and destroyed by the force of the black hole, it can be sucked down the tunnel through the ring of fire that emerges from the white hole of the parallel world. This theory is related to the theory of spacetime described by Einstein. In this theory, spacetime is the fabric of the universe, and objects of mass move this fabric, creating a platform through which other objects move toward them. Imagine a piece of paper representing space. If you draw 2 points on paper and draw a line between them, it will show the movement of objects in spacetime. But how can you fold a piece of paper in half and create a shortcut between 2 points? This is the basic idea behind a wormhole, a shortcut through space that connects two very close distant places. Wormholes are not just the subject of science fiction. It was a prediction of a general relationship, even if no one saw it right. This is because wormholes are unstable and collapse almost immediately after they are formed. However, the existence of the Einstein-Rosen bridge suggests that black holes are not just vacuum absorbers, but gateways to other regions of space. Can we use worms to travel through space and time? Unfortunately, the answer is probably no, not yet. Even if we can confirm the wormhole, it may not be usable faster than the light. According to Einstein's special theory of relativity, the speed of light is an absolute limit for the speed of everything in space. However, the concept of wormholes and black holes leading to other parts of the universe or other times has intrigued physicists for decades. The idea that there might be shortcuts in the fabric of space-time that could travel great distances, even the past, if we could, would change our understanding of the universe. One of the main topics in this field of study is the Kerr wormhole, named after the mathematician Roy Kerr. This type of wormhole looks like a ring-shaped opening, similar to the crystal from the story Alice in Wonderland.